Again, that's just the policy and the syllabus sheet for the class. You should read it over, keep it in your folder with the rest of your stuff, refer back to it if you need to. Let's see. Announcements. Friday will be our first quiz. It'll cover the material from section 1.1 up through the end of section 2.2, which we should finish today. Okay. Again, those in-class quizzes, they'll take about 10 to 15 minutes. They'll be at the beginning of class. About between 1 and 3 questions. At least one of them will be guaranteed to come from the homework. So it'll be a problem that you should have seen before. The rest of it will be filled in from either questions just like the ones on the homework or from the stuff that we talked about in class. Okay, so be prepared for that. We'll do that at the beginning of class, and then we'll finish class that day with normal presentation material. All right. That being said, let us go ahead and start in on the rest of section 2. All right, so last time what we did is we looked at graphical displays for categorical data. Okay, we saw that with categorical data, we have a couple of different choices for how we can display data. We saw that we could use a pie chart or we could use a simple bar graph. Today what we're going to do is we're going to look at distribution of quantitative data. And I realized today when I was looking at my stuff that I need to talk for just a minute a little bit more about quantitative variables. Quantitative variables come in 2 different types. And again, being able to identify the type of quantitative variable you have is important when dealing with graphical summaries as well as with data analysis as a whole. So when we talk about quantitative variables, the stuff we have to consider is what kind of values can I get out of my quantitative variable. Now, I can give you some examples of some quantitative variables, some simple examples we can look at. For example, number of siblings. Okay, that's an example of a quantitative variable. Another example of a quantitative variable is, for lack of a better one, weight. Weight is another example of a quantitative variable. Now, these 2 quantitative variables are examples of the 2 different categories that one can fit quantitative variables. Okay? When we look at the number of siblings, what kind of answers or what kind of responses can we get from number of siblings? Whole numbers, positive whole numbers, but in reality, we can get any positive integer value we want out of the number of siblings, right? I mean, the Duggars have like 25 kids or something like that, and you know, there's probably families like that all over the world that have maybe more than that. But the kind of values we get out of here fit into a finite list of values, okay? So this is what is called a discrete quantitative variable. Okay? The term discrete refers to the fact that there are only a finite collection or a way of writing down every possible answer we could get for this particular variable. Okay? The number of responses, or the list of responses that we get out, we could write it down if we had enough time. All right, now let's think about the weight variable. What kind of responses can I get here? Well, again, I'm typically thinking of only positive values. Okay? But in terms of looking at weight, the difference between this variable and the previous variable is that if I want to talk about weight, suppose you tell me you weigh 185 pounds. Okay? Is that exactly 185 pounds? Are there any grams in there? Are there any ounces? Are there any milligrams? Are there no picograms? I mean, if I wanted to, I could measure your weight to any degree of accuracy I needed to, provided I had the right instrumentation to do that. Okay? So weight is an example of a variable that's called continuous. It's a continuous quantitative variable because between any 2 responses that you give me for weight, I could find another value in between those two that's also a valid response. Okay? So continuous quantitative variables are variables in which the possible outcomes are uncountable. You can get an infinite list, and you can think about between any two of them, there is another one. Right? Another way of thinking about this, for those of you that remember your algebra or pre-calculus stuff, is a continuous variable is one in which the possible responses
You're missing an S.
Right. Thank you. The possible responses form an interval. Okay. Basically, as I said, between any two values, you can find another one. And then if you find that, you can find another one between that and any of the other ones you have. Okay. So that's what a continuous quantitative variable is. And again, why do we need to know this? Well, it becomes important as we move through statistics to be able to identify continuous variables versus discrete variables, and we utilize that when we look at some of their different displays that we'll get to. Okay. All right. So some simple ideas about quantitative variables that we need to cover again. Sort of a rule of thumb. Continuous variables, things like weight, height, time. There's other ones that I'm forgetting. Distance. Those are all examples of continuous variables. Anything that you can get out some sort of measuring stick or some sort of watch or something like that, anything that utilizes those as sort of your measurement devices, those are always going to be examples of continuous variables. Anything you can measure with those are examples of continuous variables. All right. Now, what we're going to do next is we're going to talk about some of the graphs that we can get for quantitative variables. So graphical displays of quantitative variables. Now, there are probably a bazillion different graphical displays you can think of for quantitative variables. We're going to talk about three, the three that the book uses primarily, and we'll see sort of how these different distributions are used and sort of what the ideas behind them are. So the first kind of example we're going to look at, or the first type of graphical display we're going to look at, are what are called stem and leaf plots. And you probably have seen these before, you probably know what these are, you probably know how to do them, and that's fine. We're just going to go through a little brief overview for those of you that don't recall much about them, get everyone hopefully up to speed and on the same page. But a stem and leaf plot is a type of graphical display that allows us to display quantitative variables by using the actual data itself. Okay? Stem and leaf plots actually use the data you've collected to construct the actual picture. And the actual picture contains the numbers of the data that you've collected. Right? As an example, let's suppose that I collected the following weights of people in class: 153 pounds, 147 pounds, 162, 161, 143, 150, 128, 123, 135, 210, 201, 185, and then 162. So these are some weights that I collected from a group of people. And what I want to do is I want to find a good way of displaying this data. Okay? Here is the raw numbers. These are the raw data that I've collected. Now, I don't see a whole lot of really interesting stuff looking at just this numerical data. I'd like to be able to sort of condense all this information down into a pretty picture that tells me a story about what this data means. Right? So this stem and leaf plot idea, basically what we're going to do is we're going to take all but the last digit of our data. Okay? We're going to form what are called the stems, and the stems consist of, these are all but the last digit of our data. Okay. Now, if you look at the data we have here, the stems that we're going to have are going to consist of the first two digits. Okay? So for example, the stems for this particular data value is 1, 5. So this one would be 1, 4, 1, 6, 1, 6, 1, 4, so on and so forth. And what I'm going to do is I'm going to draw a vertical line, and on the left-hand side of that vertical line, I'm going to write out all of my different stem values. I'm not going to duplicate the same stem. All I'm going to do is I'm just going to write out all of the stem values, starting with the smallest one and going all the way up to our largest one. So in this case, I'm going to start at 12 because that is my smallest stem. There's nothing here in my list less than 123. So 12 is my first stem. And then I'm just going to increase by 1 all the way up to my final stem value. Which is 21. Okay. Now, you may look at this and say, okay, well, you don't have any values up here that have a stem of 19. That's fine, you're right, I don't. There's no values here which are in the 190 range. That's fine. I still want to include every possible stem that could occur between my smallest and largest value. Okay, I want to include them all because I want this to demonstrate sort of how the data is distributed amongst all of these different categories. All right. Now, the second thing I'm going to do here is I'm going to create the leaves. Well, there's only one value left. Each of those last values is going to represent a leaf in my plot here. Typically what we want to do is we want to utilize the order of these values in putting out our leaves. So for example, in the 120 range, I have two values here that fit in the 120 range. I want to list the leaves in order from smallest to greatest. So in this case, all I'm going to do for my leaves is I'm just going to write down the last values of each value that shows up in the 120 range. Okay? So 120, I have 123 value. So I'm going to put a 3 here. Right next to it, I also have 128, so I'm just going to put the 8 right next to that. That's what I do. That's the 120 category. It has two leaves, a 3 and an 8. When I see a graphical display like this, what I should do is I should say, okay, in the 120 range, there are two values. There are two data values that fit into the 120 pound category. One is 123, the other one is 128. Okay? That's how we read these stem and leaf plots. For the 130 category, what am I going to put there? 5. I just have one value. The 5 is the only thing that goes there. So there's the 130 category. Okay, what about the 140 category? I have a 143 here. Anything else? 147 as well, so I'm going to put those two. About 150. Just the 0, that's the only one. Oops, sorry. 0, we also have 3. What about the 160 category? I have a 1, and I have a 2 that shows up twice. So I put each different one out there. Even though I have repeated values, I still want to list each one individually, indicating to me that there are 2 in that category that have the exact same value. Okay? There's 262s. Okay? What about the 170 category? There's nothing. I don't put anything on this line. Nothing at all goes on this line. Okay? How about the 180 category? 5. There's 5 there. How about the 190 category? Nothing. The 200 category? I have a 1. And then the 210 category? I get the 0. And there we have it. This is a stem and leaf plot of this data that we have right here. These stem and leaf plots can be as big as you want them to be, depending upon how much data you have. Okay? And typically, in dealing with stem and leaf plots, the advantages of using this is that with a stem and leaf plot like this graphical display, this display that I've constructed here, tells me everything about every data value that I collected. If I was just given this graph, I could go back and I could construct all of the data points that I got.